Coming up, ladies and gentlemen, is the presentation by Shri Mahipal Singh from Nokia. He is a goal-driven professional with 18 plus years of significant progressive telecom experience with an end-to-end expertise in 2G, 3G SPA, 4G LTE, radio access, transport, enterprise, etc. He heads the Technical Solutions Enterprise at Nokia Solutions and Networks India, has been heading for providing technical solutions in railway communications, public safety, government business while serving through companies like Nokia, Ericsson, Motorola Solutions, etc. Mr. Mahipal has been engaged with railways, metros, defense public sector segments, also actively contributing in railway communication modernization plans, LTE spectrum related discussions from initial stages. He feels that correct modernization plans with LTE, ETC2 and TCAS of Indian Railways shall help to improve the safety, operational efficiency and functionality. And over to you, sir, for your presentation.
My name is Mahipal Singh and I'm director in Nokia Solutions and Network. In my slides, I will try to cover the new digitizations for the Indian Railways, what is FRMCS and why it is the need of an hour for the railways. So let's start. So what are the railways key challenges? The first and the utmost challenge is the safety. Safety is the passenger safety, which related to the accidents and also with the passengers other safety, like uh, like women's safety as well as safety from the hackers also. Second and the most prominent, I can say the key challenge is stay on time or efficient operation. The trains all needs to be run on the time. They should reach the destination on time and the operation needs to be efficient. Third, on top of it, we need to make our travel more attractive with the new services. As Indian Railways, they are planning or they have already introduced, the railway operators like Tejas is one example, which is running from Lucknow to New Delhi. And we want to make this travel more attractive by, providing new services which can further add revenue to the railways. So the new services need the evolution of the network. Right now, we are using multiple communication systems like optics, and all these communication systems are consist of like some are legacy, some are of current technology, but we need to take care. This should be a future proof. So we are using a packet microwave also, we are using IP/MPLS also, we are using SDH also. So all these technologies are simultaneously coexist today. For wireless, we are using GSMR, we are using narrowband technologies like Tetra or maybe the walkie-talkies, etc. So all our offices, I can say like stations, our rail HQs, passenger announcement system, the signalings, our analog signalings are there. We are now planning to modernize these signalings to the digital or automatic train operations. So all these are connected through using these, old technologies plus new technologies. What we need to evolve this network, we need to modernize ourselves, modernize these communication technologies, and move them towards to the future proof and need to cater these to the higher bandwidth data requirements. So that's why we need a digital railways. So digital railways, basically, for digital railways, we require two kind of thing. One is yes, on the connectivity layer, we need to work a lot. Second is on the application layer. For connectivity, we need a very low latency or low latency technology with a higher bandwidth or higher data throughput. So FRMCS, 4G, 5G, these are the technologies which can, and the converse backbone basically. The converse backbone can take multiple backbone technologies, all the transport technologies into one and deliver the packets at our destination. Second is yes, train to ground communication is required for all safety critical or mission critical related communication. And on top of it, how we make our operations more efficient, how can we enhance the life of our equipments. For that, we need IoT or analytics for railways. And all this digitization is only possible with the help of automation. For that, we need to improve our connectivity layer And application layer is again, it's on like automatic train operations, ATOs are there, the signaling systems, TCAS and ETCS on which we are working. So all these need to be modernized to provide a more efficient and a safer railways. Protect these layers, we need a cyber security to protect it from hackers, to protect it from any third party, dangers. And all these things, we need to deploy all this, we need a professional railway services. So all together, they are make, the digitization of the railways is required. How today's railway exists? Today we have, in the transport segments, we have multiple types of railways, like main line is there, we have metros, light rail, we also have dedicated freight lines. Applications, we are using analog signaling today. We are planning to use TCAS. Metros, we are using CBTCs. For mission critical, we are using Tetra networks. For operational and other applications, passenger applications, we are using Wi-Fi, Space Pass, and all these different applications are using. Now, all these segments with requirement of these applications are catered by multiple communication technologies like GSMR, Tetra. They are like voice-centric, narrowband technologies, and more of voice-centric, I can say. Analog, broadband on trains, Wi-Fi, these are used for the mission critical, or I can say for CBTC, etc. However, these are like non-reliable technologies. So what we can do, we can have a one single technology which can reduce the complexity of networks, which can remove all these different 6, 7 technologies only with the one, that is LTE or FRMCS, the future railway mobile communication system. With this future railway mobile communication, we can enhance the reliability, we can reduce the complexity of the network, and we can cater to all the applications. And this same application, same, the communication network, the FRMCS can cater to all the transport segments. Now, what is future railway mobile communication system? So FRMCS is a standard basically adapted by 3GPP, and in the coming release of release 17, they are going to publish it. It's a worldwide standard, open standard, which all the 3GPP OEMs are going to adopt. Now, this is a bearer independent or a technology agnostic, I can say. So we can use any technology, access technology, basically, whether it's a 4G or 5G, or even in the future 6G also. The future railway basically defines the quality of services, the stringent quality of service required for those application layer. Now, this is the successor of GSMR. So globally, we have almost 2.5 lakh kilometers of track is already, covered by GSMR, and they are using it for various different narrowband applications. Yes, the major application is for the drivers, like messages are there, the voice centric applications are there, as well as ETCS 1 and 2 are also running on GSMR. So FRMCS is the successor of GSMR. With a low latency and also catering to the broadband data, we can cater all these applications, all these needs of Indian railways or global railways only through the FRMCS. Now, this is also enabler for the railway digitization. So one of the aspect is low latency. So low latency, we can have real-time tracking of the assets. We can have a huge bundle of data which we can collect from the remote sensors, and we can add on further applications like ticketing, which can be on the go. You can use, like the Indian Railways can use on the go and issue the ticket, reserve the berths, etc. So we have multitude of services we can achieve through the FRMCS. What is there for the drivers? Now, demand for the broadband. Why it's required? It's required to increase the operational efficiency. Now we need to improve the customer experience also. Customer wants multiple things. And most important is, again, I said, the safety, the automation of railways. Like we are now adapting or modernization of signaling system is happening. So this modernization again is all depend upon like how the low latency and how fast we can get the information. The CBTC, the ETCS, or the TCAS, how they can send the data within within a no time to the application server, so that the command can be executed. Optimization of networks, when I'm saying, yes, multiple communication technologies we are using, we need to unify all these network technologies into one, so that it can further reduce the complexity and increase the flexibility. These narrowband technologies are voice centric and almost support a very minimal data, and these are edged. Now these are going to, you can say, obsolete very soon. GSM is again It's obsolete. No innovation is happening in GSMR. Similarly for other narrowband technologies also. These are kind of aged and going to die soon. So for the long-term support, the LT or FRMCS, which is there, this FRMCS still we have like decade of support is available for these technologies, and these are upgradable and future-proof. So what are the requirement of this FRMCS? Yes, we can provide the voice including group calls, video calls, and high data requirement applications also. All train control application, ETCS, CBTC, TCAS, all can run on this FRMCS. On top of it, FRMCS also supports mission to mission critical or machine to machine interface, the telemetries, and also NB-IoT, CAT-M, all these protocols are supported. So these can help you to have, a number of applications like, predictive maintenance, etc. can be achieved. Performance communication, we have different type of requirement, asset trackings, which can be, possible only through IoT or NB-IoT technologies. CCTV, passenger information, staff, all these communication, which can further enhance the safety of the passenger. Also give you a data to, for the improvement of the efficiency of the railway networks. Business, yes, passenger internet on board. On our luxury trains, like if we talk about the Shatabdi or Rajdhani Express, definitely we want to give something extra to our passengers, so that can lure them to come again back to the use these services. So we need to introduce some fancy services also, and the one of the that most important is the connectivity, the passenger internet. Now FRMCS. Why FRMCS is better than previous and other technologies? First, it supports a variety of a spectrum. So FDD, now 3GPP has defined FDD and TDD spectrums, which we can use for FRMC. So variety of spectrum is available from 400 megahertz to 3 gigahertz. So we can use, there are 40 different bands which we can use. So it's depend upon country to country. Now India has adapted band 28 700 megahertz for this technology, whereas China is going on a lower band, and other countries, Europe, etc., they are planning to use the 700 or 1800 band for this. So it can work on multiple frequencies. Second is highest reliability. We are looking for, because this communication, which is actually we are dealing with a mission critical network. The mission critical data is going to be transferred using these technologies, using FRMCS. So a highest standard is required. So highest reliability and availability of network is one of the important aspects, which we can achieve through FRMCS. So we are committed to 6.9 here. And also the redundancy is there. So redundancy, when I'm saying there's 100% complete redundancy is there in terms of hardware as well as in terms of the software. Second and most important part, in 3GPP release 15, the cloud core virtualization concept is introduced. They said they want an architecture based on the curves. So a local virtualization and cloud core, we can implement this core concept on that. So this can have, you can have like a distributed as well as a centralized architecture. So distributed will help you to have a low latency for applications, and centralized will give you data as a central location, which you can monitor through a common location. Now, all the mission critical applications, FRMCS independent on the bearer. When I'm saying independent, it's technology agnostic. Multiple technologies can coexist, whether it's 3G, 4G, 5G, Wi-Fi, satellite. It's irrespective of it's a 3GPP technology or a non-3GPP technology. All these technologies can coexist. And only the thing we require is on the application layer, we require the quality of service. That quality of service, these parameters are again defined in 3GPP for FRMCS. These are very stringent requirements, and these are based for a mission critical communication. High speed. Today, we are planning to have, enhance the train speed from 200 to 250 kilometers in India. We are planning for that. Bullet train is under consideration. So now this speed, the FRMCS can manage a Doppler effect of more than a speed, more than a 500 kilometer per hour. So this much of speed, there's no degradation in the performance. There's no degradation on the technology. This is what this technology can do. With the introduction of FRMCS, we can have multitude of new services like the real-time CCTV. The data can be transferred from remote locations to the centralized location. We can have ticketing on the go, like the TT can on the go can reserve the berth, can issue the tickets. Passenger countings, automatically passenger countings, whoever is entering into the station, whoever is going out of the station, who is entering the train, all these passenger countings are possible with the introduction of IoT as well as the LTE technology. Other definitely the automatic train operations are there. The new revenues, yes, we can generate new revenues by using or introduction of broadband and train, by providing internet services to the customer, by using advertisement services in the train. All these are like video on the demands, audiobooks, etc. Third and the most important is on the flight, the seat reservation. All these are possible. Bistro shopping. All these are only you will provide a broadband services that will help to customer to use all these services on top of that broadband data availability. Now globally, we have, as I mentioned, we have almost 2 lakh of 50,000 kilometer of track is already covered by GSMR. In India, almost 3,500 of kilometer of track is covered by GSMR. Now, whatever the investment we put into the GSMR, we want to preserve that investment. So that investment is only preserved when the coming technology or the latest technology is compatible with the backward technology. So this is the one of the beauty of FRMCS. It is backward compatible. So GSMR can be phase-wise migrated to FRMCS. Both technologies can coexist and then integrated with each other, and slowly we can remove the GSMR and fully deploy dependent on the FRMCS. So a full path is available with the introduction of this IP technology. IoT. This is one of my favorite topic. IoT can do a miracle. If your network support, you can do a miracle from the IoTs. Today, when IoT was introduced, I can say IoT was coined in 2006. There were very few devices that are connected through IoT, in lakhs or in hundreds or thousands or lakhs maximum, I can say. Today in 2021, we have almost 20 billion of objects are connected through IoT. So these are the remote sensors which are sending data. We can mint that data to our requiremements, and whatever we want we can mint from that data. And in 2025 my expectation is this data is going to be like this number of remote sensors is going to be around 50 billion. So this is growing, I can say, exponentially. Now we have different applications for which we can use. Right now, one of the challenges, yes, the safety of passenger on the unmanned gateway. So this unmanned gateway can be controlled by IoT sensors. So if any train is going, we can put a sensors on the track. Whenever there is a vibration, this can help to close that gate, that unmanned gate, so that we can prevent accidents. Second is, yes, on the train. What we want today, for the efficiency of train or reaching on the target or a destination station, most of the failures are because of the loco failures. So we can put these IoT sensors in the loco, which can send data back to the command centers. We can analyze that data and we can make our loco efficient, and it will reach on the time. We can put this data so that in the loco, which can help us to apply brake on time, which can help to reduce this brake times also, and other aspects. So on the track also we can put these sensors to send the vibration data as well as the temperature data. So this will help like what we need in the future, how we can make it more efficient, how can the predictive maintenance can be better, so that there will be a lesser failure, a better efficient operation can be achieved. So there are multiple of applications which we can achieve through these IoT devices. And this IoT is again, you can have a single network, that is FRMCS, and IoT can coexist with the FRMCS. Automation of yards, depots, factories. So there are multiple use cases like digital factory, yard and depot automation. So with the use of these, private LTE network or FRMCS network, we can achieve all these automations. The connected workers, we can track these workers. We can have a smart asset management also. So these assets can be tracked, their data can be collected and can be used. So there are multiple use cases which we can use or achieve through the IoT. So IoT is, yes, it's introduced long back in railways. However, we have not scratched the bare minimum of it. So if we will scratch it and we'll try to put into use this IoT analytics for railways, we can do a miracle with this. So that can save a huge cost. I can say 50+% of today's operational expenses can be achieved through using can be saved through using the IoT analytics. And rest, second is, yes, it can also give a better or a safer railways. Now, what Nokia is giving? So Nokia is providing end-to-end LTE solutions for railway, which is adding a broadband connectivity for safe and efficient train railway operations. So Nokia is having end-to-end product portfolio, starting from the LTE devices, the ruggedized devices which are suited for the rough environment, comes with the PTT button, push to talk video, and a voice call. On top of it, we have a e-node Bs, which can provide a RF part, a remote tracking device, I can say the base transceiver stations, and all these e-node Bs are connected to the LTE core. So in FRMCS, architecture is very simple. You just have the user equipment, which is our mobile, I can say. Second is e-node B, which is producing the RF, and which are connected through the backbone, like IP, MPLS, or optical fiber back to the core. Very simple architecture. And on the back of the core, we have the application server. So these applications like ETCS, TCAS, MCX, mission critical voice or data services. So we have multitude of multiple application servers that can reside at the back of the core. Paris Metro. So we did a trial. Nokia did a trial in 2017 where what it done, they were using a multiple technologies. CBTC was the signaling they were using. Besides that, they were using 6 different radio networks. So these 6 different radio networks, which consist of like your, Tetra networks, the Wi-Fi, WLAN, etc. All these networks are replaced by a single silo network, that is 4G LTE. And this 4G LTE, we run all the application on this FRMCS network. Real applications like CBTC, CCTV, voice passenger information, all these applications run on LTE, and it provided a much higher, what I can say, a better efficient information as compared to their other 6 different technologies. So the network design and radio planning simulation is done by Nokia. The equipment is provided by Nokia, and we achieved the test results. Basically, it clearly said no need of 6 different radio technologies. Only a single technology can perform all the tasks with a higher performance. The target performance reached like it's a very low latency application. Whereas in the Wi-Fi, that's a non-reliable technology. LT is a higher reliable technology, which is required for the important applications like CBTC. These should be run on a very high reliable networks, uh, like LT. Nokia is an undisputed global leader in railway communication. So we have almost 120 plus railway customers. We have deployed our network in more than 2 lakh kilometers of track. And all these operators, they are relying on Nokia's mission critical network. So Nokia is undisputed leader. We are having almost 80% market share in the railways. We have a huge legacy in the railways. So we are investing a huge amount in railways so that future railways can be secure, safer, and a better efficient railways. We have 30 plus years of railways, as in covered my previous slide also. 2 lakh kilometers of track is already covered by Nokia equipment. So we have 100 and plus mission critical railway networks. And on top of it, Nokia is committed to a very high standards. So we want our legacy customers, our legacy network should be upgraded to FRMCS so that we can provide a much better, much safer, much efficient, railway networks, which can drive the future of the railways. And the good part is we have the Bell Lab, which is a pioneer in the innovations. So Bell Labs is part of Nokia, which is awarded 9 Nobel Prizes for the innovations. So Bell Lab is now dealing with the development of this FRMCS for the railways. So the development and innovations are basically in a much safer hand. So this is one of Nokia's living lab. That is our FRMCS lab, we call it. In conjunction with the Toshewan TB Railways, we have a living lab basically, which is running on the TB Railways. So in this lab, we are working on the what is the requirement of current railways, how we migrate from GSMR to the FRMCS, and how we can mitigate whatever the challenges, how we can overcome those challenges and provide a better, safer railways. Thank you very much.